Earlier in this topic, we looked at different measures of central tendency or location. They were mean, median, mode. Mean, median, mode tell you where the centre of the data is. But there are three measures of spread. So there are three measures of spread. Now, I mentioned this a few lessons ago, and they are range, interquartile range, and standard deviation. Now, range is just highest score minus lowest. Doesn't tell you much about the spread of scores. Includes outliers, like I said, doesn't tell you much. Interquartile range is that one step better. It's just the middle 50% of scores, Q3 minus Q1. And the standard deviation is the best measure of spread. All right. The standard deviation is the best measure of spread because it takes into account every single score. You will enter the scores on your calculator. Standard deviation is the best measure. So the standard deviation is a better measure of spread than the range and interquartile range because, like the mean, every single score in the data set is taken into account and affects the standard deviation. Standard deviation measures how different each score in a data set is from the mean. That's what it does. So the symbol for standard deviation is this. Sigma. Well, it's not sigma. It is sigma. It's sigma. Yes, so this, is sigma. You will have seen a different sigma like this, meaning sum of, which we use in sigma fx over sigma f. That's apparently a sigma, but a capital one. So this is also, it's called sigma n. See, because it's got that little n. So that's the symbol for standard deviation. It's sigma n. And it's the Greek letter for S, or one of the Greek letters for S, and it's pronounced sigma. And it can be calculated using our statistics mode. So we've got to go into the statistics mode. Okay, the formula for calculating standard deviation is quite complicated, and we're not going to look at it in this. It doesn't come into this topic. Okay, it's beyond the scope of the course. Okay, but there are also two types of standard deviation, but we're only going to use the population standard deviation, not the sample standard deviation. Now, you will see two symbols with sigma on your calculator. We're going to use the one that says sigma n. Here is the SX. It looks like it actually is not even a sigma on this calculator. It's SX. Notice here, oh no, here it is, sorry. It's not SX, it's this one. That is sample standard deviation. This is the proper one. Sigma X on top of the 6. That's the one we want. Not the SX. That's a sample standard deviation. Sigma X is the population standard deviation. So you want sigma X? Yeah, looking at this calculator here, it's on top of the 6 as well. Same calculator, sigma X. How do we access the green keys? Through recall sigma X when we want to do the standard deviation. Okay, here we go. The number of monthly accidents at a construction site over 8 months is all of this data here. We want the mean and the standard deviation. So to enter, remember with our mode, what do? We go mode, stat, which is number 1, and SD, which is 0. Now, it says stat 0. We then enter our data. And our first number, do you remember how to enter the data? You go 3 is my first, M plus. 3 M plus, and it says data set 1. And I've got light shining right on my screen. That's to enter the data into the set. Then we go 0. 0 M plus. And it says data set 2. So as you enter each score, my next number is, I think, 4. So the next one is 4 M plus, and it says data set 3. Then I've got the number 2, and I press M plus, data set 4, etc. 3 M plus, data set 5, 0 M plus, data set 6, 2 M plus, and 2 M plus. I've just entered all my data. I'm going to count how many numbers I've got, and it says 8. 1, 2, 3, 4, 5, 6, 7, 8. My calculator says I've got 8 bits of data. How do I do the mean? I press, do you remember? Recall. What's the symbol for mean? It's on top of the 4. Mean X bar. And the mean is 2. See, X bar equals 2. And to do the standard deviation, you press recall and which button? 6. And you look at the screen and sigma X is 1.32 to 2 decimal places. The mean X bar is 2 and the standard deviation sigma X or sigma N, it doesn't matter, is 1.322 to 1 decimal place, it's 1.3. Now, if we look at this data, I just want you to look at the mean. The average of these scores, you don't have to work it out, it's 4. This data is symmetrical. Can you see that? Right? Don't worry about interquartile range. The range is just the highest minus the lowest. But look at the standard deviation. It's 1.45. Just watch what I'm doing here. I've just moved some dots. Now, is the standard deviation bigger or smaller? It was 1.45. What is it now? How would you describe what I'm doing to the data? I'm making it more condensed. And what's happening to the standard deviation? It's getting smaller. All right, so the closer the scores are together, the smaller the standard deviation. Now, if I spread the scores out more, why isn't it changing? Don't know why it's not changing. Wait. So if I spread the scores out more, watching, the standard deviation increases. Do you think you have an idea what standard deviation is measuring? The bigger the standard deviation, would you say the scores are more or less spread out, the bigger the standard deviation? Yeah, they're more spread out. Do you see? So that's what standard deviation is. It's a measure of the spread of the scores from the middle. Now, the more the scores are to the side and more spread out, the bigger the standard deviation. So all you'll have to know is if you see a small number for standard deviation, the scores are closer together. That's all you need to know. All right? So small standard deviation means the scores are closer to the centre of the data. They're closer to the mean. See, because what's the mean for this data? It's 4, roughly, 4.1. It's 4. But the closer the scores are to the mean, the smaller the standard deviation. See? See what I'm doing? All right? Small standard deviation, scores are closer to the mean. Big standard deviation, scores are more spread out. Continuing from where we were, for this set of scores, we entered the data, we got the mean was 2, and we got that the standard deviation was 1.3 to 1 decimal place. Now we're going to do another question here and look at the standard deviation and the mean. So to calculate the mean and the standard deviation, you only need to enter the data once into your calculator, and once it's entered, you can work out the mean and the standard deviation. Mode, which I believe is mode, stat I think is number 1, and SD is 0, there for the blue calculators. Then when you enter your data, you'll be going 6, M plus, 0, M plus, 3, M plus, and so on. And every time you enter some data, it will say data set 1, data set 2. And make sure you've entered 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers. All your data, your calculator should say data set 4, depending on what sort of calculator you've got. And then we do the mean. Now to do the mean, which is the X bar button, we press recall, which is a green button. And on top of the number 4, I believe, there's that symbol X bar. So once you've got your 12 scores in, to work out the mean, it's recall, which is green. All your stats functions are in green. You press recall, and you have to see where the X bar is, and it's on top of the 4, I believe. And that should give you the mean, and what do we get? 2.25. So the mean is 2.25. Now keep that data there. You can also do the standard deviation, and the standard deviation, so the standard deviation, which is sigma x on your calculator symbol, that's recall, is it 6 or 7? Which number? Look for the sigma x in green. Where is that button? We then, to work out standard deviation, symbol is sigma x or sigma sub, like little n on your calculator, you press recall 6. Well, depends which button your sigma x is sitting on top of, and that should give you your standard deviation. And what is the standard deviation? To 2 decimal places, please. Anyone? Standard deviation, what do we get? 3.03 is the standard deviation. Now, what we're doing in the next bit is really more for year 12, but it just says evaluate the mean x bar plus standard deviation and x bar minus standard deviation. Evaluate those values, and they are 1 and 2 standard deviations below the mean. So what I'm going to do, I'm going to draw a little sketch down the bottom. I'm just going to draw a little sketch down here, and I want you to do the same. The mean we know is 2.25. And I'm just going to go mean plus 1 standard deviation down here, mean minus 1 standard deviation there. Now we know that the standard deviation, so here I know that the mean is 2.25 and the standard deviation is 3.03. So therefore the mean plus the standard deviation is 2.25 plus 3.03, which is 5.28. Are you okay with that?
No.
It's asking me what is the mean plus the standard deviation. You've just worked out the mean is 2.25 and the standard deviation is 3.03. They're asking for the mean plus the standard deviation. So you just add the two values together. But they're also asking for the mean minus the standard deviation, and that should be negative.
What's that?
Well, 2.25 minus 3.03.
No, I'm looking at the figure. What is minus 17?
So the mean minus 1 standard deviation is negative 0.78. Now, so we've worked those two out. Question D says, okay, so evaluate, so C was evaluate mean plus 1 standard deviation, mean minus 1 standard deviation, and what those values are. They've just asked us to add the standard deviation to the mean and add and subtract 1 standard deviation from the mean as well. Now, it asks you now how many of the given scores lie within those values. See how I've got mean plus 1 standard deviation, mean minus 1 standard deviation. The values are from negative 0.78 to 5.28. How many of our bits of data lie within those two numbers? That's what it's asking us in part D, okay? So I'm looking for between negative 0.78 to 5.28. Is 6 in there? No. 0 fits in there. Do you get what I'm doing? 3 fits in, 2 doesn't. 5 is in there because I'm going from negative 0.78 to 5.28. Negative 1's out, 0 is in there, 3 is in there, and 1 is in there. Those numbers are between the values. So I'm looking for between the values negative 0.78 to 5.28. How many of these values fit in there, in that range? I've got 1, 2, 3, 4, 5, 6. How many of the given scores lie within 1 standard deviation of the mean? In other words, lie between the two values in part C. I've got 6 scores, 6 of them. And what percentage corrected 1 decimal place? How many scores is this as a percentage of the total of scores? That's what it's asking. What percentage correct 1 decimal place of scores are within 1 standard deviation of the mean? It's 6 scores out of, how many were there? Weren't there 12? 6 scores out of 12 times 100%. And what answers that? 6 out of 12, girls. What fraction's that? Half is 50%. In other words, 50% of our scores are within 1 standard deviation of the mean. Okay? Just notice that 50% of the scores lie within 1 standard deviation of the mean. So next year what we're going to do, when we look at statistics next year for large sets of data, very large sets of data, find that there is generally 68% of the scores that lie within one standard deviation of the mean. I would hardly call 12 scores a large data set. Okay? Okay, we need to clear our statistics mode again. Do you know how to do that? You can either just go back in and go mode stat SD. That's the best way. Or you can go second function CA, clear all statistics. But to be safe, I'd be going back into statistics mode. Okay? Now, do you remember how we enter this data into the calculator? In statistics mode. So you've got to go mode, stat, which is 1, SD, which is 0. Now, to enter the score 0 6 times, we go 0, I think it's the STO button or the comma button, 6, M plus. Can we try that, please? Then we go 1, STO, I believe, or the comma button, 7, M plus. That's how you enter data from a table into your statistics mode. So mode stat is number 1 and SD is to press a 0, okay? Now when you enter the data and we're trying to enter the score number 0 6 times, see these 3 buttons here, recall, STO, M plus, they are your buttons that you use for statistics. So we will go 0, whoops, 0 needs to go in with a frequency of 6. We go 0, I just press 0, then I press STO, then I press 6, and then I press M plus. And it should say data set 1. And then I enter my next bit of data, 1, STO, 7, M plus. Okay, and we continue. Then we go 2, STO, 8, M plus. So when it's just single sets of data, you just enter M plus, M plus, M plus every time you put a number in. But for data in the table, I'm up to the third one, 3, STO, or the fourth one, sorry, 10, M plus. So now on my calculator it says data set 4, I've done 4 rows. Then I've got 4, STO, 9, M plus. Then I've got 5, STO, 5, M plus. And I've got 6, STO, 5, M plus. So it's telling me I've got data set 7. 1, 2, 3, 4, 5, 6, 7. Okay? Now, I need to work out my mean and standard deviation. Again, I'm using these buttons. Now, recall means, when RCL, recall. I want to recall now some information, I suppose you can think of it as. So store and M plus they are to do with putting numbers into your calculator, and the first one is how you're recalling the answers, I suppose. You can think of it like that. So if I want my mean, it's recall, and the X bar button is on top of the 4, and I go recall 4, and it shows me that my mean is 2.88. Okay, so the mean is 2.88. That's the mean, part A. And now we want the standard deviation. Well, the data has already been entered, so we come back to our calculator, recall, standard deviation is on top of the number 6, standard deviation, and my standard deviation is 1.807. Now we want it to 1 decimal place, so sigma x is 1.8 to 1 decimal place. Okay? Scores were within 1 standard deviation of the mean. Now, down here, I like to do a little thing. There's my mean, it's 2.88. I'm going to add mean plus 1 standard deviation. Now 1 standard deviation is 1.8. So if we add 1.8 to that, what do we get? 3.68. And I've got the mean minus 1 standard deviation is 2.88 minus 1.8, which is 1.08. I hope I'm right. I think so. No, I don't think I'm right. Is that 4.68?
Yeah.
Thank you. Okay. So the mean plus 1 standard deviation, because 1 standard deviation is 1.8. So I'm doing the mean plus 1.8 to give me 4.68 and the mean minus 1.8 to give me 1.08. How many scores are within 1 standard deviation of the mean? I want the scores between, I'm basically looking for the scores between 1.08 and 4.68. Okay, let's look at the table. Is this bigger or smaller than 1.08, the score 1? It's smaller, I can't include it, but 2 is in the range. Do you get it? I'm looking for the scores between 1.08 and 4.68. So I've got 2, I've got 3, and I've got 4. How many scores there? I've got 18 and 9, 27 scores. Okay, 27 scores. So I've got 27 scores within one standard deviation of the mean. And what percentage of scores are these? 27 out of, actually if you've still got your data in statistics mode, if you now do recall 0, because on top of the 0 is a little n, and n means number of scores. If you do recall 0, it actually adds up all these frequencies for you. And what do you get? 50. There are 50 scores. If I actually added all these up, there are 50 scores. So, what percentage of scores are within one standard deviation of the mean? 27 out of 50 times 100. Well, it's obviously a bit more than 50%. Percentage of scores within one standard deviation of the mean are 54%. Now, it says here for many large sets of data, approximately 68% of the scores, which is a little bit more than 2/3 of the scores, will be within one standard deviation of the mean. See this number 1 7 times? If I added that on, see 1.08, 1's very close to it. Can you see that? 1 is very close to 1.08. If I include the 1's, I'm actually going to have 34 scores if I include the 1's. Do you know what I'm saying? And that equals 68. If 1 is included, because it's very close, I've got 34 out of 50 times 100% is 68% of the scores. So it is fairly close. I mean, 1 and 1.08, they're fairly close. All right? All right. Now, for the last one, to enter this, you need to clear your statistics mode again, but you cannot enter a range of data into your calculator. You need to enter the class centre. What would be the class centre? This is for question 7 here. So what's my class centre? Isn't it halfway between 500 and 600? But if you want to do it on your calculator, it would be 500 plus 600 divided by 2. That's my class centre, which is, we know that's 550. The next one's 650, 750, etc. Okay? Now, to enter this data onto your calculator, please make sure you've cleared your statistics mode. Yeah? And then you will go, how do we enter it? 550, STO, 7, M plus, etc. 650, STO, 20, M plus. Okay? Keep entering the data and you'll just need to find out the mean and standard deviation. Has someone already done that? Someone's just given me their answer. They've said that the mean is 764.89, 119.36. Okay? If that's not what you get, just check your answer in the back. Okay?